Hey everyone, GraphDBA here again with another video, and today I'm going to show you how to use SRDF Metro so that Oracle ASM Diskgroups can be simultaneously presented from two PowerMaxes at once. But first, some boring legal stuff. Hashtag I work for Dell. Yes, I am required to add that to all social media posts, so there you go. I work for Dell Technologies. That said, my opinions are my own and do not necessarily represent Dell. Okay, next. Now, in an earlier video, I discussed SRDF replication, which is the replication technology built into a Dell PowerMax storage array. And I talked about how you could use that technology to replicate ASM disks from one PowerMax to another in either synchronous or asynchronous mode, in a manner that offers an outcome not dissimilar from Oracle's Data Guard. But I also talked briefly about how you could use active SRDF Metro so that two PowerMaxes could present the same ASM disks to Oracle database hosts. Instead of the familiar active-passive, with the clone disks being distinct from the source disks and typically read-only, with SRDF Metro, as far as you and me are concerned, they are the exact same disk, just coming simultaneously from two different PowerMax arrays. SRDF Metro for Oracle RAC is usually used in one of two ways. In this example, all Oracle RAC nodes see both PowerMaxes. And if one PowerMax should fail for any reason, the database nodes simply rely on the second PowerMax for their ASM storage. None of the database nodes would crash, even though an entire storage array went offline. This would typically be used within a single data center, where all database nodes can be zoned to both PowerMaxes. Alternatively, in this example, Oracle database nodes pull their ASM disks from only one PowerMax. In our example, nodes 1 and 2 use the PowerMax on the left, whereas nodes 3 and 4 use the PowerMax on the right. If the PowerMax on the left were to fail, for example, nodes 1 and 2 will also fail. But nodes 3 and 4 stay up, as the PowerMax on the right is still available. This configuration is what you might see with a stretched Oracle RAC cluster, the Oracle RAC database stretched between two data centers. Even if an entire data center fails, the database is still online. So we're going to set up a new ASM disk group using SRDF Metro between two PowerMax storage arrays, and we'll start with our first PowerMax, which is SIM1027. First, we'll create a new SRDF group to handle our Metro traffic. Like most PowerMax systems, this one is used for more than just Oracle, so as you can see, we've already got a number of SRDF groups set up. I'll make a new one for my needs by clicking Create SRDF Group. Now, it has already filled in the remote array to PowerMax SIM1028. I'll give my new group a name and I'll call it GruffLink and click Next. If you watch the video Replicate Oracle ASM with SRDF, then this should all look familiar. We need to choose an SRDF group number. You can pick any number between 1 and 2048, but to keep things simple, it usually makes sense to use the same group number on the source PowerMax as the target, so I'm going to use 201. Next, we need to set the local ports for this group. I'm going to select Oscar Romeo 1 Charlie 3 and Oscar Romeo 4 Charlie 9. I will show you the advanced options, but we don't need to set local link domino or the local auto link recovery for SRDF Metro. When we click Next, we get to specify these same options for the remote PowerMax, so we'll set the group number to 201 again, and we'll use the same ports. Now, if you want to, you can enable software compression, which will reduce the amount of traffic being replicated, but will use PowerMax CPU cycles to do it. If you have the optional hardware module installed, you can also specify hardware compression. In this example, we're not going to use SRDF compression. Click Run now, and the PowerMax will create the new SRDF group. Next, we need to create volumes for our ASM disks, so we'll go to Storage and then Volumes. I'm going to create 4 new volumes of 1 terabyte each. Now, I'm not going to add them to a storage group yet, and you'll see why in just a minute, but I will select Advanced Options and then change the volume identifier to name plus append number, so I can name my new volume swing data, which will then be suffixed by a number. The PowerMax will now create our new volumes, and you can see here that we have volume IDs 141, 142, 15 Charlie, and 15 Echo. If we scroll down through the list of volumes on the PowerMax, we should be able to find what we just created. Here's one of our new volumes, and as you can see, it is not in any storage group yet. So next we will create a storage group for our new volumes, and I will call this Swing Data SG, but I'm not going to add any volumes to it just yet. Next, we need to repeat all of these steps on the remote PowerMax, which for me is SIMID 1028. Now, I'm not going to make you sit through the entire process a second time because it is identical to what you just saw me do on the local PowerMax, which was SIMID 1027. At the end of the process, we will have two identical sets of volumes and two empty storage groups. So now we can pair our two sets of volumes. To do this, we'll go to Protection and then SRDF Groups, and then highlight the SRDF group we just created and select Create Pairs. Set the SRDF mode to Active and the action to Establish. The SRDF Metro group can be maintained by one or more witnesses, which will resolve a split brain scenario should it occur, or it can use bias, in which case the local PowerMax, the one we are creating the pairing from, will win. And then we get to select the volumes to pair, starting with the local PowerMax, which is the one we're currently connected to. I am going to use manual selection and search for the volumes named swing data. This is another reason why I like to explicitly name my volumes. And you might notice that I have exclude volumes in use checked, so it won't try to offer me any volumes that are being used. This is why I didn't add my new volumes to the storage group yet, because if I had, the PowerMax would consider them in use. Here I will select my 4 volumes. And now I can add the volumes to the storage group, so I will select the empty one I created earlier. And now we repeat these same steps for the remote PowerMax, selecting the volumes I created and adding them to the empty storage group. SRDF vernacular always refers to the two sides of an SRDF relationship as local and remote, even if the two arrays are right next to each other in the same data center. The local PowerMax is the one your Unisphere session is currently connected to. The target of the pairing or replication is the remote PowerMax. Okay, so we've selected our 4 local volumes and our 4 remote volumes. Unisphere will now pair them together and add each set of 4 volumes to their respective storage group. The amount of time needed to complete this step depends on several factors, including the quantity of data being synced, the number of volumes, the speed of the link, and the available CPU on the local and remote PowerMaxes. I'm going to use a little video magic to speed it up. SRDF has paired our volumes and Unisphere has added the volumes to the Swing Data SG storage group, but our database hosts cannot see the volumes yet because Swing Data SG does not have any masking views. If you watched my earlier video on provisioning Oracle ASM disks from a PowerMax, then you'll know that we have to add the storage group to a masking view that includes both a host group and a port group. In our example here, we are simply going to add the new Swing Data SG storage group as a child of an existing parent storage group, which itself is already mapped to a mapping view. The parent storage group is Oracle Discovery SG, and it already has 4 child storage groups. We can click on this and then add Swing Data SG as a new child. And of course, we have to repeat these steps on the remote PowerMax. Once we have done this, our 2 database hosts should be able to see the new volumes, with host 1 seeing the disks from PowerMax SIM 1027 and host 2 seeing the same disks from PowerMax SIM 1028. So we've created an SRDF Metro group. We've created our volumes and we paired those volumes and then added them to the storage group. And then we've added that storage group to a parent storage group that itself is masked to the database hosts. Next, we need to rescan the SCSI buses of the 2 database hosts using the SG3utils package, and then we will tell PowerPath to go look for new devices. If you decide to cross-connect your SRDF Metro configuration, that is to say that all database hosts can see the ASM disk from both PowerMaxes at the same time, then it is the multipathing software that allows this to happen. PowerPath simply sees the volumes from SIM 1027 and SIM 1028 as the same volume available via different paths. But in this example, we have not cross-connected the SRDF Metro groups. RAC node RAC N1 will draw the ASM disks from SIM 1027, while RAC node RAC N2 will draw from SIM 1028. We need to check if the new volumes have shown up on our database hosts. So if we go back to Unisphere for a moment, we can click on our Swing Data SG storage group and then navigate to the volume list. The first volume is ID 00141, and if we highlight it, we can see that the WWN ID ends 30313431. We can now use PowerPath to look to see if this volume exists. And here it is, the same volume ID from SIM 1027, and you can see that the WWN ID matches. So let's go try another one. Let's pick the second volume, which is volume ID 00142. And if we highlight that, we see that the WWN ID ends 30, 31, 34, 32. Again, let's check this with PowerPath. And there it is. Same device, same PowerMax, same WWN ID. It'd be pretty tedious to have to do this for a large number of volumes, so I pulled together this simple script to list all PowerPath devices with their WWN IDs and their capacities. You can see that we have 4 volumes at 1 terabyte each and that the WWN IDs match. We need to run this, of course, on the second rack host to make sure that both nodes can see the new volumes. And from this point forward, it's pretty basic stuff. I've said on many occasions that I'm not a fan of partition headers for ASM disks, as it makes resizing those disks more difficult if you want to resize a disk group later on by growing existing disks instead of adding new ones. But whoever set up this lab originally chose to use partition headers, and you can't mix and match. So we need to add partition headers to each of our 4 new disks. And then on node 2, we'll use the part probe command to discover these new partitions on the disk that it can already see. If we run our simple script again, you should now see that we have 4 partitioned disks. Next, as you would guess, we're going to label each of the disks for the swing data disk group. So I will source the grid infrastructure home and then use the ASM command AFD label. I'll do disk 1, and then I'll do disk 2, and disk 3. Oh, fat fingered that one. Let's try it again. And lastly, let's do disk 4. And then over on node 2, we'll source the grid infrastructure environment and use the ASM CMD commands AFD refresh and AFD LSDSK to show that the new ASM disks are present. Now let's take a moment to show that rack node RAC N2 is pulling its ASM disks from a different PowerMax to node RAC N1. Let's take disk swing data 03, which is PowerPath device EMC power BB. If we do a power MT display command against EMC power BB, we can see PowerPath report that the volume is coming from SIMID 1028. And if we now repeat that operation over on rack node RAC N1, you will see that the same disk is coming from SIMID 1027. All that's left to do now is to log in as the grid user and create our new ASM disk group. And once that's done, we can use the ASM CMD command LSDG to show that the new disk group is available. And that's it. We have a new ASM disk group shared across our rack cluster created using SRDF Metro. Our 2 PowerMaxes could be right next to each other in the same data center or up to 100 kilometers apart in entirely different data centers, depending on the needs of the database and the application. And that's a wrap for this video. Hope that was useful. If you liked it, you could click like. And if you really liked it, you could click the subscribe button for lots more graph insights in the future. And you are always welcome to come check out my usually gruff but sometimes useful blog at graphdba.com. Thanks for watching.